Hi there, and welcome back to the Frost River subdivision. I'm Mark Underwood, your host and the builder of this layout. It's been 8 months since my last video update, and terribly sorry about that, but 2016 has been an interesting year, kept me very busy with work and family issues. So thank you for sticking with me, and welcome back. I have actually 2 update videos that should be coming in short order. This first one, number 6, we're going to talk about electronics, and in the next one, number 7, we'll take a look at some track work that I've been doing. So without further ado, let's get started. Let's take a quick tour of the electronics here underneath the layout. Back here in the corner, what we're looking at is the master power supply for the layout. It is a converted PC computer power supply, 400 watt system, and I added this circuit board here, which is custom made, to keep the supply turned on and to provide connections and a switch to control the power output from the supply. So a lot of this is kind of temporarily hooked up, but these 3 power pole connectors here give me 3.3 volts, 5 volts, and 12 volt output to drive accessories, and I'm also using the 5 volt and 12 volt outputs that would normally go to things like hard disks for powering the command station. While we're over here, you can see up here is my PM42, which has 4 circuit breakers. And so I have the layout broken into 4 sub-districts, all powered by 1 booster. The 4 sub-districts are the main line, the yard, the branch line, and staging. And so that should help with keeping things easier to diagnose when I have short circuits and things like that. I'm using 14 gauge solid bus wire for the main track buses. This is the main line bus right here with these 2 connectors. It's going off in 3 different directions. You have a red rail and a black rail. So those main buses go all the way around the layout or to the specific locations they need to go. And I keep the consistent paradigm of red rail to the outside, black rail to the inside of the oval, so that I can avoid wiring things up wrong. So if we move over here, this is where the computer control system is. Here we have a Digitrax PR3 computer interface, which connects to the layout computer, which is a Raspberry Pi. It's a little micro-sized computer that I have mounted underneath the layout. So the PR3 and the Raspberry Pi are both connected to my Digitrax Zephyr, which is the heart of the system from a DCC perspective. And I have the display and keyboard for the Raspberry Pi running JMRI on here on my desk. Here is another little project that I'm working on, which is part of the clutter. I've designed this little Arduino based board. This is an Arduino Pro Mini here, and I have Loconet connectors, I have servo connectors, and I don't have the screw terminals populated, but there's 4 outputs for signal LEDs. So I'm going to make several of these, and each one will handle a set of powered turnouts on the layout, and they'll be my custom design because it's fun for me. Over here we have part of the detection system. This is my BDL168, also from Digitrax, block detection system, and this is going to handle my staging area, which has 12 separate detection areas. There are 5 tracks split into 2 half tracks, plus the 2 yard ladders or turnout ladders leading into and out on either end. And with the 4 extra outputs from the BDL-168, I'll be covering 4 of the nearby mainline track areas as well. And I have other plans for detection the rest of the way around the layout, which I'll talk about later. Bit of a rat's nest here. This is unfortunately fairly typical of my rat's nest. This here is the yard bus and a fairly typical feeder wire attachment. I have 24 gauge stranded feeder wire which comes down, and I use these 3M Scotch lock suitcase connectors, as they're called, to connect the wires to the layout, or to the bus. Behind there, this is the mainline track bus, and all the way in the back is the staging track bus. Over here, this is the midpoint of the staging tracks where these white telephone wires are hanging down. Each one of these is an infrared sensor that is on either side of the center line of the 5 staging tracks. The center line of the track would be right here. So these are going to be connected to another detection board that I'm designing, and they will allow me to stop a train just short of the midpoint of the track, so that I can stack up 2 trains on a single track and have a capacity of either 5 long or 10 short trains in my staging area. So you can also see the feeder wires coming down for those staging tracks. Again, still a bit of a mess because things are only temporarily hooked up and in the process of being wired there. And here, this is a typical wire coming down from one of my manual switch turnout throws. There's a black, red, and green wire. The green wire goes to the center tap of the switch. The black and red wires go to either side. And when I hook this up, the green wire here from the switch will be tied to the green, you can just barely see it back there in the background, the green frog wire for the corresponding turnout, and the black and red wires will be tied to the track bus. And that way, when you throw the manual switch, the frog polarity will be automatically controlled that way. Very simple system, just takes a little bit of wire and some careful hooking up. Here's another little side project that I'm working on. This is a MRC sound decoder that I have connected to this little circuit here, which I picked up from Lance Mindheim's blog. And what it basically does is allow you to plug in a pair of headphones here and listen to the sound from the sound decoder while you're running your trains without bothering the rest of the family. So works pretty well. The one problem I ran into, and I haven't figured out whether this is a MRC specific or a Steam specific problem. All of the auxiliary sounds come out great. The bell, the horn, the coupler clanks, the water pouring sounds, everything. But the Steam chuff does not work. And my theory on that is because the MRC decoder is expecting some motor feedback in order to do that chuff, although it does not have an explicit sensor feedback for the chuff sound. I think it's expecting some signals on the motor wires to make that work, and I haven't quite figured out how to do that. Lance reported that he used the same circuit, which he didn't have my little custom-made board to do it with, but the same circuit electronically with a diesel sound decoder. He used a Tsunami decoder and reported great success with it. So still some investigation to go there, but it's a good start. And I may be using this for layout sound. I also have my virtual sound decoder in JMRI that I'll be continuing to play with. Well, I guess that about wraps it up for part 6. Stay tuned. Very shortly I'll be coming out with part 7, where we'll take a look at some track work, and I also have some additional videos planned to cover a few detail items. So until next time, have a good day.